All right, let's get the show on the road. Fantastic. All right, so just a note, we are recording. If you happen to speak, you'll be recorded and this will be posted to our website and to YouTube. If you don't speak and don't have a video on, it's no problem. I believe if you make comments, those will be recorded as well, but it's just up to you if you want to participate and how you'd like to do that. This workshop is intended for intermediate LaTeX users. If you've never used LaTeX before, please watch the recording of our first video. It is on YouTube, on our website. It's pretty cool, so I'd recommend it. If you don't have an Overleaf account already, please sign up for one at overleaf.com. It's free, it's easy, and you'll be ready to do all the LaTeX things in the world. We'll have a short Q&A session at the end of the event. We'll be keeping everyone's microphones muted until the end of that, just so we don't have a lot of noises coming back and forth. If you have trouble with your code, please message me. I believe at some point we'll also have Jared and Nick with us in the Zoom chat, and if you can also ask them. But if you think that everyone's having the same problem, just put it into the chat and Dr. Cruz can answer it for you. Right? Just a couple other little things. We have some upcoming events that we want to talk about real quick. First is the application to apply to our mentorship program family. That application deadline is tomorrow night. There's also a Writing Hub workshop by the Academic Enrichment Program tomorrow, and that is centered around the Trell Scholarship, which is for research. I highly recommend it and go to that tiny URL to just sign up for that. We have a research panel on Thursday. We'll be talking about how to get into research, what kind of research opportunities are available, that kind of thing. Projects Welcome Night is November 5th, and that's where all the project teams will be talking about what they're doing, and you can talk to them individually in poster sessions. We have the last day to apply to projects is on November 10th, and then we have a GBM the same day at 6:30, and that will be with HP. It's very exciting. These are all of our QR codes for all our various things. Facebook is definitely the most populated thing that has the most recent updates. So yeah, check those out, and we will keep you posted on everything going on. With that said, we'd like to welcome Dr. Drews, tonight's LaTeX master, and he has some fantastic things to share with us tonight. I'm very excited, and I hope you all are as well. Dr. Drews, how are you doing tonight?
I'm very well, thank you, Eleanor.
Oh, good. I'm so glad to hear that.
Okay, so
should I stop sharing the screen?
Yeah, I'll go ahead and start sharing mine over here.
Right.
This one. All right, so I've got until about 6:30. So my plan was to go until about 6 or so, and then try to leave some room for questions afterwards. I'm sure we'll have a few, which is perfectly fine. I'll try to keep an eye on chat, but like Eleanor said, if it's a quick question, there's a couple other people in here that might be able to help you faster than I can. But I will try and keep an eye on chat because I imagine there'll be a few questions. We're going to start not completely redoing everything that we did last time, but we're at least going to start from a blank slate, right? So that you can get into that sort of pattern of what does a blank LaTeX document look like and how do I get started. And we're actually going to use it since we're going to add more to our formatting this time around. We're going to add a little bit more separation to try and illustrate the workflow inside of LaTeX. So remember, it always comes in two parts. I've got a blank document sitting here. Over on the left frame is the file browser. So if you have any graphics or anything like that, they're going to pop up over there. Recently, Overleaf introduced the file outline, which is in the bottom left. If you have sections or subsection headers or anything like that, they'll pop up down there in the file outline, but we don't have anything like that yet. So there's nothing there. The main one that we work on is the source document, which is sort of in the center of the page, which I'll make a little bit bigger there. And then over on the right is the compiled document. So remember, the compiled document won't update until you tell it to update. We're going to be telling it to update a lot here, but normally the workflow is you type a fair amount and then update it. There is an auto recompile feature. I'm not in the habit of using it, but you're welcome to use that too if you want to use it. Mostly because it I tend to make errors when I compile stuff, so I don't leave it on because it just looks like there's errors all the time, even though I know I'm expecting an error at the time. The general division of the document is into two parts, right? There's a preamble part, and that sets, here's how I want the document to look. And then underneath that is the document's body, which is, here's the content that I want into the document. We're going to be playing around a lot in both sections right now, but try to keep in mind, and we're going to separate the two here in a moment to better illustrate this. The idea of LaTeX, where it shines, is if you have to reproduce the same document several times, or at least the same looking document several times, you can put the styling over in one file and just move that file from document to document, and you never have to worry about those documents looking different. That's partly nice because it gives you some consistency between your documents, but the real advantage of that is you no longer have to think about what your documents look like. You know that they're going to end up looking the way that you want them, and that gives you more time to focus on the content. And so it's less time thinking about how I achieved a certain look, and more just recycling the same look over and over and over again. That gets a little bit lost in these tutorials because we spend a fair amount of time jumping back and forth between the two. But it is something that becomes a little bit easier once you actually start using it to produce your own documents, because you'll get to recycle those documents over and over and over again. And we'll illustrate on here how that can be made a little bit simpler. So the first thing that we always do is we tell LaTeX what kind of document we're interested in producing. In nearly every example that, or every document that we'll ever need to make, it's going to be what's called an article. And an article is sort of LaTeX bread and butter, right? If I just want a general few pages of something, maybe less than 30 or 40, something like that, it's probably going to be an article. And the way to tell it that that's what I want is to say that the document class that I'm interested in producing is an article. So this is the beginning of our preamble. That's sort of the minimum, right? The bare bones that I need to start a LaTeX document is to say, I want a document class and I want that class to be article. Remember the backslash here is the shorthand in LaTeX for I want this to be a function, or I'm trying to call a function that's called document class. And then most arguments to functions are given by these curly braces. Optional input arguments are given by square brackets, and we'll get to more of those in a minute. Then the body of the document is given by two more functions. One of them is called a begin, and the argument to this begin is document. And the other function is called end, and the input to that function is called end document. The begin-end pairing is one that comes up a lot, and that is also called an environment. So the begin-end document series defines the document's environment. Everything in between there is in the environment that we would call the document. And those are the two big portions of the LaTeX document, any LaTeX document. And so usually I'm in the habit of giving them a little bit of space just so that I can tell the difference between the two. In order to actually get content to show up, you can obviously do the classic hello world. And if you hit recompile, that should be the sort of bare minimum to just get text to show up, right? The words hello world will show up over in your document, and now you're sort of off to the races, right? Whatever kind of content and modification you want to make, you can start from here and know like at least the core of it is ready to go. What I'm going to do now is introduce some of the same packages that we used last time. I'm just going to go through them a little bit faster. So we're not going to go through every possible use of each of these packages because we went through those in the previous one, as well as some of the options to the packages. And I can see that my right eye is a little bit lighter than my left. Let's get that. Oh, too bright. Let's leave that one. Okay, there we go. Better. The first thing is setting the font size. There are not infinite font sizes in LaTeX, so you can't pick anything that you want, but a really common one is an 11-point article. And so I put the optional input argument here to the document class function to say that I would like my fonts to be in 11-point. We can also use a package. So remember, anytime that we want to perform a general change beyond the very core functionality of LaTeX, which is pretty much every time, we have to use a package to do that. That's actually to your advantage because a lot of these packages have specialized syntax that makes your life easier. So using packages is good. One of the packages that is used almost every time is the geometry package. And the reason for that is because this sets the page size. It can also easily set the margin. So for example, if we want the margins everywhere to be 1 inch, we just say as an optional input argument, margin equal to 1 inch. I should also note that the standard page size for the geometry package is actually A4, which if you're from Europe, it probably sounds familiar because A4 is the standard size over in Europe. And most of the time when you export these things and print them, you'll never even notice that it was A4 because most PDF viewers will just automatically scale everything to whatever your printer is. But your printer, at least if you're in the US, is probably not A4 paper. It's probably letter size paper, which is 8.5 by 11. And so we can give the additional input argument to geometry to say, make this a letter, which is 8.5 by 11. That letter is not the same as article, right? Those are two separate things. Letter in the geometry package means the size of a document is 8.5 by 11 inches. So we're going to use letter sitting there. And then we'll introduce a few more packages which were standard previously. So I'm going to do something a little bit different here, which is to actually separate every one of these packages line by line, which is a little different from what we did before, but the reason for that will become evident in a moment. One of the reasons for that is we can just comment them. So this is setting page size, right? So I can add a little comment. Let's reduce this size over here a little bit. The geometry package is setting the page size. I could also do another very common one, which is Math PTMX, which is to set Times New Roman as our font. And that's a choice not just because Times New Roman is common, but we also have a tendency to typeset a lot of stuff in math. And so we need a symbol set, a character set that has a full set of mathematical symbols so that we don't run into the situation of letters in math looking absolutely nothing like the rest of them. And that can show up sometimes. It's not so much that the alpha in Times New Roman is distinguishable from the alpha in some other package, except that it can have like very thin strokes, very lightweights, or the baselines can be ever so slightly off, and it can lead to weird looking things. So there's a handful of packages in LaTeX that are excellent for math, and Math PTMX is one of them. Another very common package that we're going to use is Ams Math. So this allows for a lot of different math environments and commands, which we tend to use a lot just because we typeset stuff. Another package that we used last time, actually that we're not going to use this time, was GraphicX, which was if we wanted graphics, or listings was how we included code. I don't plan to do code or graphics in this particular example, so I'm not going to include those. We did one which was called lipsum, which is filler text. Right, that just gives us the ability to throw in text wherever we need it. And I can't think of too much else right now that we had used previously that we're also going to use this time. But let's just use sort of an example here and say, I don't know, introduction in our body, and then we're going to say lipsum 1 to 2. That'll give us 2 paragraphs, and then we'll do another section of, let's say it's background. Actually, since these tend to be homeworks, let's divide them as problem 2 and problem 1. And remember, we're going to put an asterisk next to the section. And we'll just add a comment here, asterisk prevents auto numbering. And then in our problem 2, we'll throw, I don't know, lipsum 3, right, which is the 3rd paragraph of the lipsum text. And let's recompile this and see if we've got any errors. Great, we've got one. It's always nice to try to interpret what the error messages are coming out of LaTeX. So let's take a look at it. Letter undefined. So apparently I need to get rid of letter over here. There we go. And since that was evidently an error, I'm just going to Google really quick, LaTeX set page to letter size, because evidently I've got the wrong syntax. So, boom, 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 boom. And I will post this over in our group chat here in a minute. A4 paper. Paper size. Ah, I forgot the word letter paper. So what we actually needed here was not the word letter, but letter paper. How did I figure that out? I Googled it. I said Google LaTeX paper size to letter, and Googled this. So the page that I was using, in case you're curious where I ended up looking, the overleaf documentation is fantastic. So this is the link over in chat that I was using, and I just kind of scrolled through there until I found the setting that I needed in order to set the paper size to be letter paper. It barely changed the view at all. In fact, I couldn't even tell a difference on that view because letter paper is really close to A4 paper anyway. So if you forget that you needed letter paper, you probably won't notice much of a difference unless you're trying to print. Like I need a square to be exactly 1 inch by 1 inch when it actually prints, which is remarkably hard to do. Only in that kind of a circumstance would you actually really need to set letter paper, but we got it fixed up there. So one thing that would help you in a homework assignment is to have a header and a footer on there that sort of says, here's my name, here's the homework that I'm working on, and maybe which problem that I'm working on or which class is it for or something like that. LaTeX does have some built-in header and footer control, but it also has a nice package called the fancy header footer package. So we're going to use that package. So the package that we're going to use is called fancy HDR. HDR stands for fancy header. And obviously footer as well. Anything that can handle the header can probably handle the footer as well. And that's going to give us the ability to affect our headers and footers. If you just use the fancy header package and you don't give it any options, right? You don't customize your header and your footer at all, it's not going to do anything. The very first thing that you need to do in order to say, I would like a particular page to be following the fancy header footer format is to set the page style. And this still stays up in your preamble, but there's an extra function that's introduced with the fancy header package that's called page style. And you set the package or the page style to be fancy. That's why we sort of, or that's how we denote between a fancy header style and any other kind of header style. It might seem like kind of an extra step, right? I've already said use the fancy header package. Why do I also have to say set the page style to be fancy? The reason for that is because the bigger documents often have different header footer styles depending on the content of the page. So for example, if you're in a textbook, if you're writing a textbook, I don't expect you to be writing a textbook anytime soon, but if you go dig up any old textbook, you'll notice that the headers and footers don't turn up on the first page of a chapter or often the last page of a chapter. And so there's ways that you can set that. They also look different if they're on a landscape oriented page compared to a portrait oriented page. And so you can affect you can cause an effect on the headers and footers by defining different page styles. We're always just going to end up using page style fancy. So it just will always kind of feel like it's unnecessary, but it is. If you hit recompile now, we should see a mild change. Yeah, which is that we have our first sort of evidence that we are using a fancy header, which is that you have a line running across the top of your page. And so what we want to do is sort of customize the content in there. And at this stage, all we're interested in doing is having exactly the same content on every one of our headers and footers. We're not interested in, make the odd headers look this way and the even headers look this way, or make an auto update for any particular content that's up there. So that comes in several different functions, I guess, are required to do something like that. The first is we want to start from a blank slate. So the first thing we want to do is say /fancy header footer is empty, right? I have an empty brace there, and all this does is clear the header and the footer. So this guarantees that nothing will show up, which is good because we want it to show up exactly the way that we're about to specify it without any of the defaults from the header footer package. And then we're going to just define the things that we want. So if this was a homework, maybe for my, 114 class, maybe the left header, we would want to say CENG 113. So that's the function /lhead is CENG 113. So this sets the left header to be equal to the words CENG 113. The center header, which is CHead, might be which homework we're working on. So maybe that's homework 1. And maybe the right header is our name, right? So in my case, that's my name, author name. And then, I don't know, maybe the footer, let's put the page numbers over on the right. So the right footer would be page/the page. That's the only auto update that we're going to use. So if we say page./the page, it will now show up as page dot whatever the page number happens to be. There are other functions that you can use other than /the page that will get different things to show up automatically. So there are ways to say, which section are we on, which chapter are we on, which homework problem are we on, all that kind of stuff. It's usually more effort than it's work for shorter documents like this. So I wouldn't worry about it too much unless you're just curious and you've got an itch that really needs to be scratched by putting a particular piece of content in your header or your footer. If you need to do that, I would dig up the documentation of the fancy header footer package, and they've got 5 or 6 different examples of common things that you might want inside of there. Other ways to figure out how to get stuff to show up is to just Google LaTeX put section header in, header, or put section number in footer or something like that. So if I recompile this and actually shrink it a little bit, let's take a look at our document. So we've got our nice CENG 113 up here on the top. It says homework 1 over on the middle. And then on the right, it's our author name, which is me in this case. And then down on the bottom, we now have page.1. And that's a pretty good setting, right? Don't try to kill it with your header and footer, trying to make it fancier than it really needs to be. That's usually far enough, right? The simplicity is usually nicer than complexity on most of these documents. It gets the point across, and that's it, which is fine. We're almost to the point where, oops, I don't want to change that size, where I wanted to illustrate why it is that I'm separating these packages, whereas last time we just kind of linked them all in a single command for a use package, and we separated them all by commas. But let's add one more thing to our preamble before we illustrate why that is divided the way that it is. There was a question on the survey that Eleanor sent out about how do we add color to a package. My first advice to you is don't. If you're going to print in color, it's going to cost you more. And B, most documents don't have a lot added to them just because they're in color. A lot of the color will come from things like the graphics that you put in there, right? Plots will have color in them. Tables usually will not. But color in text is usually not done. But it can be done. It's one of those times where the reason that it becomes difficult for it to be done inside LaTeX is it's usually not done. Style guidelines in most documents are the text should just be black and the paper color should be white. So it ends up being more common that you don't need the color functions. So not surprisingly, if that's the standard, LaTeX doesn't exactly make it easy to make color, but we can do that. If we wanted to do that, we would use, LaTeX has a few built-in color functions. So we can see an example of that. Let's say we go down here and we want this sentence should be in red, right? If I recompile that, obviously it's just going to be in black, right? There's no indicator to LaTeX that sentence should be in red. here's the sentence that I typed, right? This sentence should be in red, but obviously it hasn't become red. The way to do that is through the function called /color, which just takes a single input argument and says /color red. If you do that, a number of things will happen. The first is that we get an error. And so this is one way that you can track down what your error messages really mean. One of them is to look at what did I write in the source code over here and what actually showed up. So evidently LaTeX knew that this was going to be a function, right? It's color, but then the word red showed up over here. That should be a quick indicator to us that we're missing a package, right? We tried to use a function. LaTeX didn't know what to do with the function, so it just kind of said, I don't know what you're trying to do, but here was the argument to your function. That should be an indicator to us that we're missing a function. The more obvious indicators that we're missing, that we're missing a package. The more obvious indicator is there's a red X here. And if I hover on that, and you guys might not be able to see the hover because I'm sharing my screen this way. If you hover on the red X, it should say undefined control sequence. That means you're missing a package, right? LaTeX doesn't know what that function is. And the technical name for functions in LaTeX is a control sequence. And so it doesn't know what that is. And then finally, if you actually look on the log, it will say that I don't know what red actually means, or what the function color actually means. And it's just kind of giving you a general error statement for that. The package that you need for that, so we're going to say use package xcolor. xcolor is an extension of the original color package. So this is sort of the extended color package. It gives you some more capabilities. And honestly, as I sit here, I can't remember if it's xcolor or color X, because sometimes they use X followed by the package, or sometimes it's the package followed by X. So let's just give it a shot and try and recompile here. Okay, I happen to get that one right. So the package to give us control over a color is xcolor. And we kind of got what we wanted, right? Which was, we definitely got that sentence in red, but we got an awful lot of other stuff that was also in red that was not supposed to be in red, which seems kind of counterintuitive, right? I just wanted a particular thing to be red. So the way to tell LaTeX, I only want this particular chunk of text to be in red, is to surround it in curly braces. So I'm going to put a curly brace in front of color red, and then one at the end of the sentence. This sentence should be in red. If I do that, LaTeX will now interpret that to mean I just want that individual chunk to be in red. All of the standard colors are built into LaTeX, so things like red, blue, white, green, magenta, black. I don't think they have brown. Sort of those base colors are built into LaTeX. If you want more colors than that, then xcolor has some ways to define custom colors. And I'm just going to leave those up to you to find them if you want them. The easiest way to do that is to just Google LaTeX xcolor define color. And it will introduce several different ways for you to define various colors. But like I said, colors in text don't really come up very often. And I don't recommend that you use them unless you have a particular need for them. The most common place that I can think of colors showing up is in cross-references. And we'll get a little bit more to that here towards the end of today's lecture, I think, if we have a little bit of time. But generally colors don't come up very often. So think long and hard if you really need a color, because chances are you don't, at least if it's on a homework package. If you do need a color, then I would point you to the color package. And most of the documentation there will give you examples of how to set custom colors, how to load like a giant set of standard colors so that you don't have to define every single color. There's different ways to do that sort of stuff. You can define colors in RGB space or CMYK space or HSV space or whatever you want to do. But that's about as far as I'm going to take colors. The harder thing to do is define background colors. I really suggest that you don't do that. A, it's hard to do, and B, it's usually not desirable for most of these documents. And that it sort of illustrates a shortcoming of LaTeX. If you need something that's quite colorful and has a lot of graphics, LaTeX may not be the right platform, right? It's got certain use cases and other places where it's not so great. If you need a lot of variations in your document in terms of background colors and highlight colors and call out boxes and that sort of stuff. And for that matter, lots of weird looking graphics, and maybe the whole thing's only like a page, like a flyer might be, maybe LaTeX not the place you want to go for that. It can probably be done, but it might throw you for a loop trying to get it to be exactly the way that you want it to be. More common is math and stuff like that. And there were a couple of questions about sort of how to handle bigger math sections. And that's what we're going to focus on for about the next 15 minutes or so, because we can actually cover a lot of interesting stuff for math. Before we get to that, I wanted to introduce or sort of come back to one of the things I had mentioned earlier about the workflow setup in LaTeX of having a preamble over here that sets this is the way that I want the document to look, and then the actual body of the document over here that says here's the content of my document. Something that might be helpful for you so that you don't have to rewrite your preambles over and over and over again is to just have a single preamble file, right? Maybe you want all of your homeworks to look the same. You can just have a single preamble file. And so the way to do that is to start a new document. And the way to do that inside of Overleaf is if you look over on the left side above where it says main.tech, and I'm going to hover on it, but again, I don't think you can actually see a hover. So okay, use the participants window where you've got the yes, no checks. I am currently hovering on new file. Put a yes over in the participants window, the little green check if you can see the word new file, and a no if you can't. Okay, perfect. You guys can actually see it. So right there is how you introduce new files. So click on that and you'll get this window. Hopefully you can see the window, but you'll just get an add file window. And you can enter any new file name that you want. I'm going to call it my preamble and click create. So it'll be mypreamble.tech. And if I look over in my file, I'll see mypreamble.tech. If I click on that, it's completely empty, right? But what I can do here is actually take my entire preamble and stick it inside of here. So I'm going to go back over to my main.tech, and I'm going to highlight everything in the preamble, and I'm going to cut it, and I'm going to put it over in my preamble.tech, right? So I just moved it from one place to another. And now over in main.tech, I'm going to use the function /input my preamble. This is essentially copy paste my preamble.tech and put it inside of this document, right? And that's it. The input command is exactly the same as if I were to copy paste everything in there. The compilation procedure will be to go read the document class 11-point article, and then when it sees input my preamble, LaTeX will jump over to my preamble.tech and go through exactly every one of these in the order that it's shown here. Right, and now my document is a little bit easier to look at, right? It's just this. Eleanor, I see the word that over in chat, but I don't know what that means. Oh, yes, that is cool. I happen to enjoy that particular one. You can also change things, right? So maybe in the preamble over here, you can sort of leave these as defaults, but if I didn't want the header to be homework 1, you can override it over here and say head, maybe I actually want this to be homework 2. Right, and now if I recompile this, I've actually overwritten the old homework header and said this is now homework 2. This also sort of leads to the next sort of clarification that you can have. Let's say that you don't want to switch back and forth between different homeworks, right? You had a homework 1 and a homework 2 and a homework 3, and maybe somewhere in homework 3 you remember, I had to type exactly that same thing over in homework 1. Can I just go copy paste it? You could, but the way that the document is set up right now is you would have to actually exit out of this document, go over into the other one, load it, find the stuff that you want, copy it, hope that you don't copy anything else in the meantime, get out of that one, load this one, paste it, etc. An easier way to do that is to actually have one preamble, and then all of the different homework documents that you would ever need. So the way to do that is let's make a new file, and we can call this one homework 1. And we'll create another one called homework 2. Right? These are separate, by the way, from main.tech. So we go over into homework 1, and let's get this preamble. So the beginning of homework 1 reads the same. I'm going to sort of delete some of the stuff down here. Right? This is sort of our template homework now, right? So we can say, I still want it to be an article. I want exactly the same preamble because it's still going to be a homework, but I want this one to be header of homework 1. Right? So that's all I have to change, and I retain all of that formatting. And then for homework 2, I can take exactly this template, move it over to homework 2 and paste it, and just update this number. Right? And then whichever one is currently being worked on, so if I click on homework 1 and I recompile this one, it'll just compile homework 1, which it didn't in this case, but let's take a look. What did I mess up over here? Every one of those should have worked. I'm going to have to track down my, oh, there's no content, right? I forgot the actual content. It won't compile if you don't have any content. So let's just put hello world in here. Sometimes the error is hard to track down because it's so obvious. Right, so now I've got homework 1 over here with the appropriate header, but I know everything else is going to be the same. We could even say that this is homework 1. And if I recompile that, I'll get homework 1 that sits on there. And then I can go over to homework 2 and say this is now homework 2. And if I recompile that one, I get to keep all of the same formatting, right? So it's very easy for me to switch back and forth between different homeworks without having to back out of one document set and go into another document set. And that's the idea of a LaTeX project. So when you first create these documents, LaTeX doesn't say, would you like to create a document? It actually says, would you like to create a project? This is sort of the reason why you would create a project is because you have an idea in mind where you need lots of documents that kind of all look the same. They share lots of similarities. And this gives you a way to quickly navigate within those documents and keep things the same, right? I can just leave everything with the same preamble, and then if I have some content in one homework, I can make it show up in another homework because it's in the same place. It's very easy to access, and relatively minor things need to be changed in order to update those documents. So that's sort of the idea behind LaTeX, right? If you have an idea for a document that doesn't fit well inside of that sort of niche, you might be a little bit outside of where LaTeX can really shine. This is the kind of thing that LaTeX can do that really shines really well. Is to create similar documents with similar typesetting over and over and over. So if this is AIChE, maybe you want the same slides to show up every single time, right? No matter where you're going with AIChE, you always want AIChE slides to show up. This would be an example of a project structure that you could do of having all of the AIChE slides use exactly the same preamble, and then you just have different files for which presentation was which. Cool. So I'm going to keep working inside of homework 1. And now I want to do some examples of, let's knock out SI unit X real quick to get units in, because that one will be fast and I want you to know how to put units in. And then we'll keep working on some extended math stuff, because we'll do units and chemistry, because that'll lead us nicely into how do we do more complex math operations. And we have some shortcuts for that. So let's say you're doing, I don't know, a fluids homework or maybe an energy balance homework, material balance, energy balance homework, something that's got units in it. If it's engineering, chances are the numbers you're dealing with are units. And suppose we just want to kind of briefly summarize what the units are for various properties of water. So the density of water is about 1,000 kilograms per cubic meter. Density of water, its viscosity is about 1 Pascal a second. Actually, this is liquid water, not gaseous water. And its heat capacity is about, I always forget, I think it's like 4,100 joules per kilogram per second, or not per second, per degrees Celsius, something like that. Correct me in chat. I never remember the units of heat capacity for liquid water, but I think it's 4,100 joules per kilogram per Celsius, something like that. But if I recompile that, it's going to look like crap, is the short way to say that. This is not the SI standard for what units should look like. Kilogram/M3, the 3 should be superscripted, right? Pascal/second, Pascal dot second. That's not terrible. It's legible, right? People will know what you mean. And then the 4,100 joule/kg-c, that's got a couple of different problems. A, you can't actually tell where the C is, right? Whether it's on the top or the bottom. You just have to hope that people are familiar enough with it to know where it is. And also there's no degree symbol on C. Another common problem of writing units is often the spacing is wrong. So believe it or not, there are rules as to whether or not there should be a space between the number and the unit. There should be a space between the number and the unit. But this is actually incorrect, to have 1,000 and then kilogram/cubic meter without the space. We could hack our way through that and try to get something that looks semi-reasonable if we were to do something like this. So I've added a space here, and then after the 3, I've used an inline math environment. So if you don't remember an inline math environment from last time, A, go check out last time, but B, it's a $sign. So put a $sign at the beginning and then a $sign at the end. And then in between there is what we call an inline math environment. And so I have _3. And _3 just means put 3 in the superscript. Now we're getting better, right? This is closer to what SI formatting actually looks like. But we're not actually to the point where we want SI formatting, because you can imagine it'd be a giant pain in the neck to try to do that for all kinds of different units. It would be nicer if we had a shorthand way to do that, and we do. There's a built-in unit or a built-in package. I shouldn't say built-in because it's not really built in. There is a package in LaTeX that allows us to do that, and it's one that I have as part of one of my defaults, right? I use it on everything because it comes up so much, and that is the SI unit X package. So this allows us to have numbers with units. There used to be an old SI unit package, and somebody extended it, so now it's SI unit X for extended SI unit package. If you use the SI unit X package, it gives you access to an SI unit function. So if we switch back over here to our homework 1, where we have this 1,000 kilograms per cubic meter, instead of that, we're going to say /SI. Right? /SI gives us the ability to say, I would like a unit or a number, and I would like to have it a certain set of units on top of it. So that same 1,000 kilograms per cubic meter becomes 1,000. And then to specify the units, it's / whatever the units is. So if I want kilogram, it's /kilo/gram per meter cubed. Kind of like, one step forward, 2 steps back, right? On the step forward, this is obviously pretty readable, right? In the sense that if I say this out loud, kilogram per meter cubed, it's obvious that I want a kilogram per meter cubed. And so if I recompile that with the /SI command, I will get this. And I'm actually going to zoom in a little bit more so that we can see some of the variations. The SI standard for typesetting units is to use just a plain old number with no symbol in front of it when it's in the numerator and a negative sign when it's in the denominator. And that eliminates any ambiguity as to whether or not, there's a divided by with a unit and a dot. Well, does the dot mean that it's in the numerator or the denominator? The SI standard is to have a negative in the exponent to denote things that are in the bottom. So similarly, the 4,100 joules per kilogram could be /SI 4100 /joules per kilogram per Celsius. Where's my 4100? There we go. Right. This is now formatted according to SI standards. You can see here now it's maybe more like one step forward and one step back, right? This is obviously quite readable. It's kind of a mouthful because there's a lot of stuff there. But at the same time, I didn't have, it's a lot easier to say /Celsius than it is to go find what the circle is and then know that it's to the -1. The package again is the SI unit X package. So over here I added /use package SI unit X. That'll let you use what we're doing here. Sure, no problem. And then just for demonstration, let's say that you wanted to have a unit by itself without the number. Occasionally you do, right? Where maybe you want to say its viscosity is about 1, and for some reason you didn't want to, actually its viscosity is, let's say it's /mu, right? And then you wanted a separate statement that says the units of mu are something, right? You wanted them to be Pascal second. There's a corresponding function to the /SI that doesn't need a number argument, and it'll just print a unit, and that's lowercase /SI. And so the units of mu are something like Pascal seconds. Right, so that can come up often when we need to define, oops, I forgot, it's just second. Sometimes not even sometimes, I frequently make that mistake. Sometimes we just want to define the units of a variable without having to say a number associated with them. And in order to do that, it's /SI. I don't know that that's going to come up quite as often on a homework problem, but it'll maybe come up. So it's useful to do it when you need to. So I said those are sort of, on the heat capacity one, sure, that unit's kind of complicated. So it's nice to be able to just say joule per kilogram per Celsius. On the density of water one, it's not quite as nice to say something like /kilogram per meter cubed, because it's kind of a mouthful and it gets a little bit tiring to type that every single time. And so there are shortcuts for stuff like that. For example, if you want the kilogram to show up, it's just /kg, right? The very same thing that we would normally abbreviate /kg for is just /kg. And so that makes it a little bit easier. If this was actually 4.1 and we wanted it to be kilojoules, then we could just say /k capital J and we'll get a /kilojoule or a kilojoule unit that shows up on here. Right, we just get a nice kg, and so those shortcuts exist throughout the system. I don't think there's a shortcut one for meter cubed. There is a shortcut for meter, which is just /m. So /m cubed, I think, is about as close as you can get to meter cubed, something like that. If you're curious what the other units are, you can look up lots of them inside the SI unit X documentation. A particularly convenient one here is per kilogram per K. K is a Kelvin. It's not actually a degree Kelvin. It's just called a Kelvin. And so you can get away with a shortcut here. And kilojoule per kilogram per Kelvin now reads /kj per kg per K. That's more like 2 steps forward and no steps back, right? That's a very nice way to typeset your units very quickly and ensure that they're always correct. The downside to the SI unit package is obviously it's only for SI units. There's a workaround if you wanted to create your own unit. You can always define your own units. So maybe it's 61. I think the density of water is something like 61 or 67 pounds per cubic foot, something like that. And you wanted to have those sort of imperial units in here. you can define new units by saying declare SI unit and then slash whatever you want your command to be. So maybe you want it to be a gallon, and then however you want it to show up as a unit. So declare SI unit gallon followed by gal would be use the word gal whenever you want to use a gallon. Another common one might be declare SI unit slash foot as FT. Right, so this now allows you to sort of quickly put all the common ones in there, you know, BTUs, feet, gallon, yards, whatever you want to do. I don't know of a corresponding package like SI unit X to do imperial units. Maybe there's an imperial unit X or something like that. But honestly, I don't use them that often. So I usually just define them once. It's also nice, right? This whole package setup or this project setup allows you to just define them once and not have to copy paste them every time you want to do a new homework. They all just sit in the preamble, and anytime you want them, maybe if you forget, you look over at your preamble and say, right, I forgot it's gallon instead of something else. So if I wanted to use gallon, I would come back over here and say, maybe it's not per meter cubed, but maybe it's per gallon, right? So I say slash gallon. And now my density will say 1,000 kilograms per gallon, right? It'll treat GAL just like a unit and use it that way everywhere. There's a couple of other built-in functions. I'll just point out the last one, which is liter, which is L, or actually the word liter. Liter is a very common one, so it's worth noting that you can also get kilojoules per liter just with /L. So you can very quickly typeset all of your units, kind of as long as they're SI. I think I'm going to sort of bump into my Q&A period by about 15 minutes because there's still math and chemistry stuff, and I seem to be talking longer than I thought I would. So SI unit X will give you lots of units, and then you can customize them if you need them to be something else. You can do all kinds of weird customizations too, to have like subscripts and superscripts in your units. So if you took 113, or if you're going to take 113, there's a unit that often is grams of catalyst or kilograms of catalyst or pounds of catalyst. And it's usually written as sort of like kg sub cat, CAT on the bottom. There's ways that you can do that kind of stuff too. But I'll direct you to the documentation for SI unit X because those are actually written clearly inside of there. And then the last one I wanted to do before we get to math is chemistry. So if we wanted to write, you know, chemical reactions. So let's say we wanted the molecular formula for water is H2O, for carbon dioxide is CO2, and for methane is CH4. Right? If I compile it this way, I won't really get great looking formula, right? H2O, people will know what you mean if you say H2O, but it is a little bit ambiguous because the 2 is not subscripted, whether it means H sub 2 or it really means H with 2 oxygens sitting on it. So again, like the units, you could try to hack your way through it and put an inline math in front of around the 2 and put an underscore mark there, and you'll get the 2 to go down, right, the way that it should, so H sub 2O. But just like with units, it becomes really annoying to do that all the time. And so there's a nice package that was written, I would assume, by some chemist who's really into LaTeX, that will typeset nearly any kind of chemistry thing that you want. Radicals, bonds, Kekulé diagrams, however you pronounce that, triple bonds, single bonds, double bonds, reaction arrows, all sorts of stuffs. What's the one with the water? I can't remember, like something bonded to a bunch of waters. There's a name for whatever that structure is, but if that gives you a clue how often we need that structure, I haven't used it in like 10 years, so I don't remember what that structure is. Anyway, the package that we want is called MHChem. So I'm going to go back over to my preamble, and I'm going to say use package. Oh, it's on the tip of my tongue. Hydrates. That's what it is. Hydrates. use hydrates a lot, or I don't have to typeset hydrates very much. If I had to typeset a hydrate, I would Google MHChem typeset hydrate, and I would just assume that somebody has an example of that because they probably do. So this is chemical formulas. MHChem. MHChem has a mild oddity to it, which is they came out with a lot of versions and they're not always backwards compatible. And so they recommend that you specify the version that you're interested in. The most up-to-date version is version 4. So we say version equals 4 here. If you don't throw that version equals 4 in there, sometimes you'll get a warning that, hey, you should probably put a version in there just in case you try to compile this at a later date. And sometimes you might get an error. Because you might be trying to do something that's only available in a later version. So this one, you kind of need to put version equals 4 in there. And then MHChem is great because it's intelligent enough that for all of the basic molecules that we ever have to do, all you have to do is put /CE and then put the molecule you want inside the /CE. CE, I believe, stands for chemical equation or chemical expression. So I'm going to say /CeH2O. I'm going to say /CE with CH4 inside, and I'm going to say /CE CO2 inside. Right, and I'm going to compile those. And voila, that is so nice. It's one of the, after SI-UnitX, this is probably the one that I use most often, and it's the one that I, again, after SI-UnitX, now that I am so used to seeing them typeset correctly, it's the one I pick up on fastest when somebody screws it up. And I mentioned this in my first sort of part 1 of LaTeX is it's kind of a double-edged sword, which is you make great looking documents, but they also make you accustomed to this is the way it should look. And then you get frustrated when you don't see it that way, right? You'll start seeing CO2 and the 2 is not subscripted and you'll kind of wince a little bit and you'll be like, that 2 ought to be subscripted. And then it'll be worse, right? Because it'll be something like CH4 and it'll be subscripted wrong and you'll kind of wince again and know it's not supposed to be that way. And it'll get you mildly frustrated that there is such an easy way to do that. Maybe you wanted to do, I don't know, CH3, CH2, CH2, CH3, right? Some kind of butane molecule or something like that. You just write the molecule out and it automatically gets subscripted all the way along there. So it's fantastic. The CE package works really well with math. And so that sort of segues into the last thing that I wanted to talk about, which is how do we do a little bit better with math, right? How do we do more complex things in math? We'll demonstrate a couple of those. The most sort of direct link between the two of how do we do something in math that we haven't really done before is to write a chemical reaction inside of a math environment. So let's say that we wanted to write, I don't know, the isomerization. Let's not do isomerization. That one's a little bit hard. Dehydrogenation of butane to something else, because I don't remember off the top of my head what the other molecule is that is produced is, let's start an equation environment and end an equation environment. Right? We would like a numbered equation, but we actually want the equation to be a chemical reaction instead of math, right? We don't want it to be math. We want it to be a chemical reaction. And so here we can just write /CE, and now we can actually write our whole reaction in a pretty easy way just by typing out what we want it to be, right? And not having to worry about subscript, superscript, find the forward arrow, find the reverse arrow, all that sort of stuff. So we could say CH3, CH2, CH2, CH3. Maybe it's a reversible reaction. So the reversible reaction sign is the left arrow with an equal sign followed by the right arrow, the less than equal, greater than equal to sign. That will give us a reversible arrow. And then the things that we get in dehydrogenation is H2 plus, I don't know, it's going to be something like CH3, CH2. I'm just going to say CH2CH because I don't remember what the other one is. It's not important right now. And we recompile that. Oops. What did I forget? Oh, I think it's just that empty white space it's complaining about. Yeah. don't put white space in there. Here we have our chemical reaction, right? It automatically drew the back and forth arrows. It gave us our molecule on the left, it gave us our molecule on the right, and then it gave us whatever's over here on the right afterwards. The stoichiometry is right, but I don't know what that molecule is. Maybe the bonds got shifted around. But at any rate, we've got ourselves a nice chemical reaction that sits there. And you can do all kinds of crazy stuff to this if you want to, right? You can put the little curly braces underneath it and you can say, this is the ethanol molecule and this is the hydrogen molecule and all sorts of things over on the other side. Right, an equation with chemistry now looks the same as the equation with math, which is great. The CE thing, the CE package or the MHChem package plays nicely with math environments. And it's pretty easy to do stuff like that. So if you ever need a reaction like that, there you go. If you want an irreversible reaction, let's just do another one. And the reaction which takes place, here we go. The combustion of methane is, all right, the combustion of methane is pretty much irreversible. So I would say /CeCH4 plus some amount of O2 is pretty much irreversible. So the irreversible reaction symbol is just a hyphen with a greater than sign, is going to go to some amount of CO2 plus H2O. I don't remember exactly what those are. Let's say that it was unbalanced. And if I had to balance this really quick in my head, I need carbon's already balanced, and then the hydrogens, I'm going to need 2 hydrogens on this side. So I would say 2 space H2O, and that'll give us 2 oxygens on this side. So I'd say 2 space H2O, something like that. Right, so that's just so much. I mean, I can actually write it the way that I would normally interpret it, and it actually shows up the same way. You can also put variables in there. So now we're going to get a little bit more into the math side because I know we wanted to do that. Or the general combustion of any hydrocarbon. So generally C sub X, H sub Y. I think that's how we do that. I'm going to have to remember. This one I haven't done in a while, so we might have to mess around with the typesetting here to make sure that I get my stuff correct. Yeah, I did. So C sub X, H sub Y. I could put math in the subscripts of the formulas. So if I wanted X, maybe Y generally has a form to it, right? Y is usually equal to, what is that? Number of carbons, so X, there's a pattern to it. There's 2 of those and then plus 6 plus 2, right? So 2x plus 2, I think, is the generic. Yeah, Eleanor beat me to it. The generic formula for a hydrocarbon is that the Y on the H is equal to 2x plus 2. So if you want to, you can throw math in the bottom, right? Wherever you need to do something like that. And similarly, you can put variables inside the equations of chemistry. So if the generic equation is C sub X, and I always screw that up, X, H sub Y, plus some amount of O2 goes to some amount of CO2 plus some amount of H2O. Right, I can leave those as variables. Obviously, I'm not doing all the math because I don't remember how all of those balance out, but if you really needed to. Now your equation can have variables in it, right? The stoichiometric coefficients can have variables like A, B, C, or if you think back to 113, or when you get to 113, you could have like nus in there, like nu sub A, nu sub B, nu sub C, that sort of stuff. So you can mix and match the chemistry and the math very nicely with the CE pack or the MHChem package. So nice molecules. Not a problem anymore. Those are easy to typeset. Nice units, SI standard units, very easy to typeset. Again, you'll pick up some patterns that we use very frequently. At the beginning, it might be kind of annoying because you know what you need to do and you don't know how to do it. And so you might have to Google around a little bit. But two things will help. A, practice, because you'll get used to it. And B, if you use this sort of project style of organization that is default in Overleaf, you can have all your homeworks in one place. And if you just remember, oh yeah, I wrote that before, I don't remember the syntax, but I know it was in like homework 2 somewhere, you can flip over to homework 2 and scroll through it and figure out pretty quickly where it was. Okay, last thing, let's do some more complicated math. We're just gonna write some more complicated expressions. The best thing for figuring out how to do math is to find somebody who's already done it. And believe it or not, there's a lot of websites that have already done it for you. I'm going to leave you with one that I think is sort of the most comprehensive. It's not the easiest to navigate, but given that I happen to read that book for fun, it's a useful resource for you to have. If you swap over to Google and search for Feynman Lectures, Feynman is spelled Feynman, lectures. The very first link that's up there should be the Feynman Lectures on Physics. If you don't know who Richard Feynman was, he was a Nobel Prize winning physicist. He worked on quantum electrodynamics. He's got a bunch of great lectures that are videotaped, but they're way back from like the 60s or something like that. So quality is not always great, but he's just this amazing, I want to say scientist, right? He did amazing work in science. He was an amazing communicator, an amazing lecturer. They asked this Nobel Prize winning physicist to come back and teach an undergraduate undergraduate introductory physics course. And it just takes a very different view of physics. So if you're ever curious about it, all of those are now available for free online. For our purposes, they're really nice because they've the entire 3-volume set, plus I think one more, his notes down here, have all been typeset in LaTeX. So if we go over into volume 1, I'm just going to pick one. You can pick any one of them that you want. What's a good one? I like Brownian motion. Kinetic theory is good. Sure, let's go into kinetic theory over here in chapter 39 of volume 1. Pick any of them. It doesn't matter. You can do all of this in any of them. Any of the equations that show up on this entire document are actually typeset in LaTeX. And so you can often get a good idea of how to do something if it's already been typeset somewhere else. So let's say that we wanted, where's a decent looking, here's a good one, right? PV is equal to U over 3 photon gas, right? And there appears to be text inside that equation. And you wonder, how did you get text inside that equation? Well, it happens to be typeset in LaTeX. If you right click on it, let's use that participants window again, because I want you to be able to see this. So can you see the pop-up that just showed up? Put a yes over there. It should say like show math as and math settings and that sort of stuff. Perfect. Right click on any equation anywhere in the Feynman lectures, say show math as tech commands. And then if you click on tech commands, I'm not sure if you can see the pop-up that just showed here. I cleared all of your responses. Can you see the MathJax pop up right now? Okay, you can't see it. I'll just copy paste it over into Overleaf rather than try to show it all over again. I'm going to copy paste that and I'm going to put it over here. This is what popped up, right? When I said right click, show math as tech commands, the equation popped up, right? So here is PV U over 3 / text photon gas. So this command is evidently how they got the words photon gas to show up, not looking like math, right? It just showed up as text. They used a label in here. Let's not worry about the labels yet. So I'm going to delete that. Yeah, that's a fantastic site, by the way. If you're ever bored and want to read physics, the approach that he takes to physics is very conversational compared to most physics books. So it's a great reference or resource if you've never used it. But at any rate, it's also a great resource if you're trying to figure out how to typeset something in LaTeX. And you can find at least an example that looks close to what you want. So there's one example, is just find it and use it that way. Let's take another example. Let's say that we want to write something more complicated like the definition of a derivative, because that's slightly larger. I'm just going to go through and type it just as an example of something that is a little bit more complicated. The definition of a derivative is, and don't hold me to this as the definition of a derivative because I might screw it up. End equation. We'll give myself some space up here at the top. I know over on the left-hand side is a fraction, right? And it says something like, let's use x and y, right? dx, dy. So in order to get that, I want a fraction. So the numerator of the fraction should be dx and the denominator should be dy. And I know I want that to be equal to something, and I'm not sure exactly what. So there's my dx dy. Oh, and my PV equals U over 3 photon gas. The other thing that I want is a limit. The command for limit in LaTeX is /lim. How do I know that the command for a limit is /lim? I just happen to have done it a lot. But also, if you don't know, just Google LaTeX math limit, right? Something like that. We'll do it pretty easily. So then that limit is a fairly complicated fraction. I know there's a numerator and a denominator involved. In the numerator is the value of the function, which is x. I think it goes, I'm trying to remember. I think it's x evaluated at x plus delta x. I think I'm going to need this somewhere else. Let's, instead of dx dy, let's do f, so that we can write f of x. Sure, there's a common one, x plus delta h. Yeah, let's do that. See how often I define the limit of a derivative? It doesn't happen very often. I know what to do with a derivative, but when was the last time you ever had to define a derivative? I remember I lost points on my Calc 1 exam because I forgot how to write this, and evidently I still haven't remembered it. Let's say f of x plus h, what is it? Minus f of x, I think, is on the top. Divided by h on the bottom. Does that look accurate too? You're on the spot now, Jarrett. You started us. You got to double check us and make sure that's right. Yeah, I don't know either. Let's just focus on how to typeset limits, right? And let's not worry about whether or not we remembered limits correctly. You can blame me if you want for that, because my Calc 1 was much longer ago than yours. And then we need that limit to actually say as h goes to 0, right? Because we need a really tiny step on there. I think, and this is another one that we have to figure out whether or not we've got this correct or not. We need h to go to 0, right? I'm just going to say I don't remember how, and come over here and Google LaTeX limit. Beautiful. LaTeX, the very first, there we go, even overleaf has integrals, sums, and limits. Let's just go check out the syntax, right? Here's some integrals inside of text, got some products, got some limits. Hey, that's really close to what I need, right? If I zoom in on this, I need something that looks like the limit of something as something goes to something else. So the syntax to that is /lim subscript x to whatever I need it to be. So I'm just going to copy that from here and go over here. Let's zoom back out a little bit and paste it. But I don't want x going to infinity. I want h going to 0. Right, there we go. Now I've got my limit as h goes to 0 of f of x plus h minus f of x over h. if you were being, I don't know, somewhat pedantic and it wasn't clear to you that the limit was for what followed it, you could surround that in /left and /right with a parenthesis opening each one, or I should say a parenthesis opening the first one and closing the second one. And you'll get a nice big old set of parentheses on either side of that. There was a question from the survey of how do we build up more complicated math expressions. This is how I would do that, right? I would start off fairly small with something that I know to be right, and then add things like grouping parentheses or fractions in numerators and denominators as I go to build something up. So, you know, another way to do that would be, say we wanted the heat capacity. Say the heat capacity of water can be expressed as the polynomial. This will be my last one, and then I'll open it up for questions. Let's even use the shortcut equation environment, right, which is just slash with a square bracket. Something like C sub p is equal to a plus b times t minus t ref plus c times t squared minus t sub ref squared, and then let's just say slash natural log of t. Just give us a variety of different things that we need, right? I started off so that in my mind, I know what I want, right? What I want is t's minus t refs and t ref squared and all that kind of stuff. The syntax, the actual formatting of that was terrible, right? It didn't come out any way that I wanted it, but it's close enough that I can interpret it as that's what I meant, right? I've got the chunks where I need it. It's just not formatted correctly yet. And so now I go through and I apply the little formatting the way that I want it to be. So I know this first t ref needs to be entirely subscripted. And I also know that it needs to be plain text, right? Ref is a short for reference state. So I would put slash text here. And I know that has to be the same way over here. So I would say text over here as well. And then I might just check it, right? If I'm doing a lot of new things that I'm not sure about, that I haven't done before, then I'm going to check it, right? Probably by recompiling it in small increments. And as long as you don't have a massive document, that's not that bad, right? You can recompile things as you go. You can also add the same way that you can put math inside chemistry, you can put chemistry inside math. So maybe I want this to be with a superscript of H2O, right? So that we know that this is the heat capacity of water, right? I can put caret with an opening brace followed by slash CE H2O. And now I get a nice heat capacity of water in my superscript up there. So if you have a more complicated mathematical expression, my suggestion is to start out simple, right? Break it down into its component parts that you know how to typeset. And then as you need to add complexity to it, focus on those individual elements. And until you're comfortable with it, try recompiling it after each time you add a new piece of complexity to it. And that way you'll know where the mistake is, right? It'll just stop recompiling and you'll know, okay, just undo that change and try something else. Until you get really comfortable with it, and then you can just start writing them. You get so used to the syntax that you can write it very quickly. For example, most of that, I probably would have written that fairly quickly. The last two things that I would change are to get those parentheses to be the right size. But now I'm in a situation where if I had just written that for you initially, it would be kind of hard to figure out that those are what we were after. And actually, see, I just screwed that up. The second one was supposed to be right. There are some tricks that you can do of separating the equations line by line. So if there's lots of chunks to an equation, but you need them to all show up in one line, you can actually add lines in between each one of these. So there are no lines here, right? Which is kind of hard to see, but if I make this longer and longer, you'll see that that entire expression is actually all on one line. It's okay if you do a plus, and then you go down to here, and then you go down to here, right? Or even just a. I mean, if you wanted to be, really spread things out, you could do something like this. Right, that will also work, but you often have to kind of play games with it because it won't always compile perfectly the way that you want it. Sometimes you have to add percentage signs to tell it, don't split the line there, but generally it works the way that you want it to work. And so that's another way that you can write more complicated math, is to actually break it up and go line by line for large chunks of math. And that can help you with the word wrapping a little bit. So I know I took up a lot of our Q&A time, but I've still got a couple of minutes. So I want to stop here so that you've got time to ask me any questions that you might have.
What's the technique for breaking a really long equation into 2 lines?
2 lines, like 2 lines that would show up over here on the compiled document?
Yes.
That would be a line. So you have to change your environment. So this one used to be begin a line and end a line. This is what we had done on whenever the last one was. I think it was also a Tuesday. Begin a line and end a line will allow you to break them wherever you want, and then align them based on whatever you want. So if you wanted this to be heat capacity of water is A, and then you wanted to bring the plus B onto another line and the plus C onto another line, you would put this over here and then do a double backslash, and the double backslash says break the line here, and then an ampersand says make all of the alignments here. And so our next line, I like to give blank spaces just so I can see where the line is separated, but those blank spaces are not necessary. Would be something like this. Right, and then double backslashes after each one of these will force it to be aligned on each one of those. You also get them numbered, which if you don't want them numbered, maybe you don't want to use an align environment, you can always use align with an asterisk, and that will get rid of those numbers for you. Right, if you just want to write a really long expression with no numbers, you can do something like that. And now if you were to scroll over to the right with align asterisk, there is no number over here. Surprisingly enough, not very many equations need that. It's mostly the align environment comes up more often when you're trying to do like a derivation, right? Where you're trying to show that if I keep substituting things in, they will eventually become that. So don't take this as an example of something that's commonly done. We don't often break equations that way. It's usually only if we have to derive something.
Anyone else has any questions? Now's the time. There's so many things you can do with LaTeX. But
I'll give you another one. Just I'm not going to show you how to do it, but if you want to learn how to be annoyed at things being typeset incorrectly, the derivative here is typeset incorrectly. So if you don't have any questions, but you don't know where to go next, try to figure out how to typeset derivatives correctly. There's a package that will do it for you. It's called the physics package. Your math professor gives us the option to use LaTeX to do our exams. Is it recommended? I mean, personally, yes, but only because I'm familiar with it. If you need to get practice with LaTeX, or you want to get practice with LaTeX, then sure, go for it. If you're stressed for an exam, though, I don't know that I would compound the stress of an exam with trying to figure out how to make it look right in LaTeX. If the other option is write it by hand and take a picture of it, maybe do that. but it sort of comes down to personal preference, right? Can you typeset it fast enough? It wouldn't do anything more than, I think, give you brownie points. How do you add a blank line? That's really hard to do. That's one of those things where it seems harder than it should be. Because there's two ways that you can, there's actually multiple ways that you can define what do you mean by a blank line. There's blank lines in the sense of, I want a line where there should be text, but I need it to be sized the same size as text would normally be. But there's also, I need space in between things, and maybe I just need some blank space. Those are two different things. If we take, let's say I wanted space in between the paragraphs here, which I'm going to preface this with, don't do that. Let LaTeX be the guide for whether or not space should show up, because usually you make the documents look worse if you start throwing space in places where it's not expected. But notice in our source document, there were 2 lines between the first paragraph and the second paragraph, but then when I compiled it, there weren't any lines. One way that you can tell LaTeX, no, I'm serious, I really want a blank line after that, is to use the same line break character that you would use in a system of equations, which is the double backslash. So I highlighted it here. It comes after the first paragraph, and then I have a blank line afterwards, and that will force a line skip in between paragraphs. Again, I can't say often enough, don't do that. Let LaTeX decide things like what gets indented and what line spaces show up on there. There's another one where if you really need vertical spacing in between 2 things, there's a command called Vspace. And it takes an argument of how much space do you want inside there. So let's say I want 1.5 inches. I would say /Vspace 1.5 in, and it means 1.5 in, right? And it will give you 1.5 inches in between there. So that's how you can force things like blank lines or vertical spaces or things like that. But the use cases for that are fairly small. Usually we use those when we try to align like 2 graphics next to each other and we just kind of have to bump one down a little bit. Maybe we'll add some vertical white space. Or if we need a break in between things, like I need a figure to be here and I need text above it, below it, and I need to specify what that text is, maybe we'll use the line breaks. But they're more for getting things to work than things that should be used in the normal course of formatting things. If you find yourself doing that a lot, you might be writing a document that's more easily written in something like Word, where you can sort of shove things around just by hitting enter a few times, because that's harder to do in LaTeX.
We have hit 6:30 now. I hope everyone has had a wonderful time in this workshop. Dr. Dees, you're welcome to stay around and answer more questions if anyone has any. Otherwise, the event is officially over. Please remember to sign in at the tiny URL that Diana dropped in the chat. And yeah, I'll be sticking around if anybody wants to stick around with me. But otherwise, have a great night.